Okay, we are going to begin with doing different translations, reflections, rotation. We're going to be doing 3 in one question. Normally in a question you'd get only 2, but in the question I'm going to put here, you're going to get all 3. Just so then we cover all the bases in one question. So here's the original, and here are the coordinates of these points. Now we're going to rotate it 90 degrees counterclockwise. Rotating it counterclockwise will go in this direction, the opposite direction of a clock. So A is 1, 4. It's going to end up to be 4, 1, but in this quadrant is negative, positive. So 1, 4 will become negative 4, 1. And B, which is 3, 2, will become negative 2, 3. And C, which is 2, 1, will become negative 1, 2 in this quadrant. So now all I have to do is find these points in here, and it'll be rotated. So negative 4, 1 will be right here. Negative 2, 3. Negative 2, 3 will be right here. And negative 1, 2 will be right here. So here is the triangle rotated. This is A, B prime, C prime. So we've done this movement. Now we're going to do this one, which is translate down 5. So every single dot is going to go down 5. So 1, 2, 3, 4. Here's the new A. 1, 2, 3, 4. Here's the new B. And C, 1, 2, 3, 4. And here goes the C. Now this graph was drawn by hand by me, so what should be happening is I'm creating congruent triangle after congruent triangle after congruent triangle. Every triangle should be exactly the same in every single way. On a graph, you would notice that better. Right now, because it's hand-drawn, you're not going to notice it perfectly. But if I check the dimensions according to the graph lines that I've made, it will be exactly the same. Now we're going to reflect it off of x equals negative 1. So x equals negative 1, which I'll draw the graph mirror with orange so then you see it. So the mirror is going to be x equals negative 1. X equals negative 1 is right here. Okay? So this becomes the mirror. This orange line becomes the mirror. So we are going to be counting everything from the mirror and then repeating the process on the other side. So this is on the mirror. So the distance is 0, so it's going to stay 0. B is 1 away, so it's going to end up 1 away on this side. So the final location of B is going to end up here. Then A is 1, 2, 3 away. So now it has to be 1, 2, 3 away on this side. And now we have A, final destination. So here's C, A, and B, and the final result. So this is your final result. After doing a rotation counterclockwise of 90 degrees, translation down 5, and the reflect off of x equals negative 1. If they say x-axis, it's going to be this. If they say y-axis, it's going to be this. But if they ask for a specific spot like this, you have to go through that without going through anything else. Okay, so now we're going to move this up so we can work on dilation. Now, dilation scale factor and dilation scale factor here, I have one that increases and one that decreases. Okay, so here we have a scale factor of 2. So that means that the distance from the origin, because the dilation is happening from the origin, the distance from the origin has to multiply by 2. These coordinates are the distance from the origin. So in reality, you just have to multiply these by 2 and you'll know where the end result is. So instead of negative 1, 1, the D prime is going to end up at negative 2, 2. E is 2, 1, so E prime would end up at 4, 2. Why is this happening? Why is it changing? Because the scale factor is 2, so I have to multiply everything by 2. So the last one, F f prime would be at 6, -4. And that's it. Once you put these, that is the dilation complete. So -2, 2 is d prime. 4, 2, so 4, 2 would end up being here, and that's e prime. And then 6, -4 would end up here at f prime. So our new one is this big triangle that is right here. So this triangle is a dilation. Okay, it's gotten larger. So if dilation means multiply, how would you shrink it? You would shrink it by multiplying by a number that's less than 1, which is, in this situation, 1/3. So this one is going to shrink. And it's going to shrink the distance from the origin. So not only is it going to shrink, it's going to pull it in this direction as well. Just like this one. It didn't just get larger, it got larger from the distance from the origin. So again, I wrote them all down. So if I'm multiplying by 1/3, in reality, I'm just dividing by 3. So all of these coordinates are going to divide by 3. So instead of -6, 6, it's going to be at -2, 2. So -2, 2 would end up right here. Instead of -3, 3, it's actually going to be -1, 1. And instead of -6, 3, it's going to be -2, 1. So it shrank to make this little itty bitty triangle right there. And that's it. That's what dilation is. If you need more clarification on rotation, translation, or reflection, I'd watch my video called Transformations, and you could work on each one individually in that video. And that's it.